Hello. I'm very excited today to talk about something that has to talk about retention modeling. This has been one of the more um, transformative projects in, and initiatives in recent times in multiple companies. I'll show you a couple of papers from Google, but also this is in the general world of recommender systems, modeling long-term rewards and not just immediate rewards has been has helped recommender systems truly deliver value, like deliver value in a way that users that leads to higher NPS score or user satisfaction. We'll talk about one specific aspect of it today, um, but the basic idea is to see the effect of a recommendation as it pertains to the full session of the user, the full trajectory of user actions, particularly in a repeated environment where you have multiple recommendations one after the other, which is quite common nowadays. Um, so let's look at a few um, published work prior to this that talk about this, that have laid the foundations for future work. So this paper by Google was one of the first to talk about using long-term rewards. They cover a lot of ground here, but for our article, we'll specifically talk only about the mathematical foundations of looking at the entire trajectory. So here, it's of course a seminal paper. I highly recommend you to read this. But the section here in the third page, I think the nomenclature and the treatment of, um, of how they define the reward and um, on the effect of um, like the past actions on the future, on the availability of the future reward. There's a nice formalism around this. So, for instance, if you look at section, they say the reward of a trajectory tau is just the sum of the reward from all the points, length of the trajectory, and then they derive the math and they use it to optimize. We'll not go into that. Then this is the another Google paper that I want to highlight here, particularly around the nice treatment of how they have explained the problem with optimizing for long-term rewards. The authors say these long-term outcomes, however, are much harder to optimize due to the sparsity in observing these events. What they mean is that very rarely, like suppose you're saying, oh, if the user is going to come back more often than they have done previously. This is a rare occurrence. It's much more common to see whether, let's say in a video recommender system, much more common to see the user is watching a video or not watching a video, or liking a video, sharing a video. You have a lot of data points, but actual changes in their um, session, the number of days they come in a week or something like that, the illness of the user, all of those, the changes in those are very rare. And second, they say is there is a low signal to noise ratio, the weak connection between these long-term outcomes and a single recommendation. So once you make an intervention like a recommendation to the user, the immediate response of it you can clearly attribute to your intervention or attribute with a high confidence. But for a long-term outcome, to attribute that to that for instance, if I show you a recommendation and let's say normally you come every 3 days, but this time you came back to the app in 2 days. But I have not just shown you one recommendation, I might have shown you 50 in that session. So which of those led you to come back a day sooner is is a very weak attribution. These two papers, besides being, very foundational papers, I think they help understand the complexity um, and also the foundations of the space. Okay, so coming back, the general area of long-term rewards is complex, and it is the problem, or there are two problems. One is sparsity of signal and low weak attribution. Here we are going to limit ourselves to entry point retention modeling. What do I mean by entry point? So by entry point, you can assume, let's say there's a recommended experience where you have multiple um, recommendations one after the other, a feed or a chaining experience. By entry point, you could look at if this chaining experience is started by, for instance, a carousal, then choosing the right entry point to that chaining experience is one example. Again, the basic idea is that these recommendations don't just affect the immediate reward, but also affect the reward of the chained experience after that, the session after that. This is one example of an entry point that we are claiming could be optimized for not just immediate but long-term rewards. Another example of entry point could be when you go to, let's just say, a tab which has, so here it was a primed experience, a seeded experience where you chose something and that started the chained experience. But then there are many apps where you have a tab where you can you go to the tab and it um, shows you a bunch of recommendations. So in that case, the first video, when you open the tab, the first video or the first item or the first recommendation, that is what we are calling entry point here. Obviously, this is a simplification, or this is um, a specific definition of what is long-term rewards in this setting. In theory, every single intervention, every recommendation has an opportunity to affect the long-term outcome. We are just choosing to limit ourselves to the entry point because, as we will show in the math below, it has a high effect of the uh, behavior in the entire session. Okay, so far what we've talked about is that retention modeling has been worked on in a number of state-of-the-art recommender systems. Here we will talk specifically about entry point recommendations. They can be the recommendations in a carousel that lead to a chained experience, or recommendations in a tab, the first recommendation in a tab, which primes the user whether to what to expect in this session. Okay. So actually, before we come to benefits, just want to reiterate what is the difference here. What is the delta between what users normally do and what we are doing? Normally, when you're building a feed or ranked feed, usually people build it in a way that it optimizes for the outcomes from that recommendation just directly, like what I might call as point-wise rewards. In the context of um, a Netflix recommendation, whether you watch that video, you like that video, share that video, everything is about that recommendation. Here, we are claiming that in addition In addition to the point-wise rewards, we should also look at long-term rewards. The rewards, whether that recommendation leads to a successful session. Okay, so not just immediate, but also long-term. Okay, well, what are the benefits? Again, I'm not quoting any numbers, but in my experience, retention modeling in the carousal entry point. So this was the carousal entry point, right? Choosing a video here, choosing an item here, choosing choosing the right item in the carousel here can lead to a reduction in the number of single item sessions. If you recall, once you tap something on the carousel, it was going to start a chaining experience, right? That's why we called it the carousal entry point to a long-term session. And we're saying that often you find sessions that are just the first entry point. Like again, in the video recommender system example, you tapped on the thumbnail of a video in the carousel. It opened up, you watched that video, and you stopped there. That would be a single video session, a single item session. So our entry point retention, if done right, can lead to a reduction in the number or percentage or fraction of single item sessions. It can lead to to longer sessions. So the average session length can be longer, both in duration and in number of items consumed. An increase in just sessions. So it leads to increase in daily active users and them having more sessions, like opening the app more daily, more frequently. And correlated with all of these, it can lead to increased revenue. It depends obviously how the app monetizes this. But usually most apps have a higher chance of monetizing if the users are coming back more and they are staying longer. Similarly, retention modeling in the feed entry point, like when users are, when there's a tab of content and they are directly going to the feed. So the entry point was the first item in that feed. So if done right, if that first item is recommended, being cognizant of the long-term impact of the entire session impact and not just the immediate impact. So if done right, it can lead to a reduction in the skip rate, in an increase in the session length, and an increase in sessions and daily active users. Of course, increased revenue correlated with the above. So again, choosing the first item in a chained experience, first item in a tab in a chained experience, can lead to some similar like measures of users getting more value from the recommendation. Not just value in terms of that particular item, but in terms of the entire session, and in terms of retentive value, them coming back for more sessions, or them coming back more frequently as daily active users. Okay, so we talked about the benefit. Now let's first talk about the implementation or possible implementation, and then we'll come back to look at some maths, and then we'll try to end with a conjecture. So our key insights were that optimizing the entry point purely by point-wise rewards ignores their long-term effect. Entry point recommendations can affect the value of the full session because the recommendations affect not just the value you get from that item, but also the probability of exiting at that point. And if you exit, you don't get any future value, right? So entry point recommendations have a huge impact on the full sessions. If for instance they are causing a lot of exits, and reduction to exit have the um, will increase the probability of them getting more value in the session. So you expect to have a higher impact of improved entry point recommendation on users who don't have entrenched habits. So this is saying that a lot of the benefit of better entry point recommendations are to users who don't have who haven't yet found a very convincing product market fit. Like users who have already got into a habit of coming all the time or having very long sessions, chances are that you will not have too much of an effect in their behavior patterns by improving the entry point recommendations. It can be a defense move, but at least unlikely to be offense there. Users who are infrequent or even marginal for you, if you focus on improving the entry point recommendations, these are the user cohorts that you will see a higher impact. That makes sense, right? Because they have not yet made up their mind, and if you get them to stay longer, then hopefully they get to see more value and they find a reason to come back more often. So, entry-point recommender systems that are responsive, which means based on the actions you take in the first item, if the recommender system knows how to change the second, third, fourth items, then entry point recommendations can affect your like the value the user is getting, not just by the intent that they generate of engaging with your application, but they can also generate intent by choosing items at the beginning such that there is good follow-on content to line up. I'll give you an example. I think I also wrote about this back in blog in 2021. Imagine you are on Amazon Prime and they're recommending videos to you. Let's say they have two options. One is a movie, and the other is the first video of a series. Now, the movie, it'll generate some intent of watching more, but unless the movie has sequels and stuff, it might not be able to show you very similar content after that. On the other hand, the pilot of a series, if you like that, then there's a lot more content to follow up. So one of these choices, now the movie with the pilot of a series, one of these choices is especially better because you have good follow-on content that is topical to this one. And this kind of works only if the second recommendation knows that, hey, if the user watched the pilot, then we should recommend the episode 2 or something, right? So the responsiveness is an assumption here, and it doesn't outside the setting of Amazon Prime, and where there are a lot of shows, etc. In a more general setting, this problem is a little bit harder. It's harder to find what is this related videos that capture the intent. I'm just trying to say that in the case that the recommender system is responsive, then the entry point recommendation can affect not just by intent, but also by topical similarity to content that you already have and is high quality. Okay. Now that we've talked about the insights, let's figure out one possible implementation. So assume these are your sessions. I'm just taking some examples. Again, I've taken the WT being watch time. I've sort of taken this video recommendation example in keeping with some of the examples above, motivating images above. So imagine there are these sessions. This is one session, this is another session, this is another session. The way we are defining our label is for the first video in each session, we are defining the label as a decayed sum, a discounted sum of the future watch times. So for the first video, we are, apart from the normal point-wise rewards, we are defining a downstream label, which is WT2 plus K times WT3 plus K squared times WT4, so on and so forth. Obviously, for if there was very short session, this was a very short session. For instance, pathologically, let's assume the user just consumes WT1 and then does not watch anything. So the first video led to the user exiting the application. In that case, the retention label would be 0 because there would be nothing to sum after that. So what you could do is through some post-processing pipelines, you could generate these labels for the first video, add these tasks to your normal multi-label estimator model. There's some technicalities about how much delay might be caused by your pipeline, etc. Not go into that. Suffice to say, along with your immediate point-wise rewards, you can add your retention labels, which are discounted sums of future value in the session. And then once you have these predictions, you can, assuming you have some sort of way of combining multiple predictions, also known as value model, then you can experiment and figure out what is the right weightage for these tasks. So once again, to implement, we looked at the entire session after the first item and computed a discounted sum of rewards and added it as a label for the first item. Model it, and we try to predict it. You might need to do some like discretization or bucketization, etc. Sometimes regression. And naturally, what I said looks like a regression label, and that has its own problems. We can cover separately some tricks to move from continuous labels to 0 to 1 labels. But yeah, that has some complexity there. But along with your normal point-wise rewards, we'll add some long-term rewards, and hopefully to the same model, and then try to figure out the right weightage your value model to for these new tasks. Right means you probably want to optimize for some core user value labels, user value metrics like sessions or daily active users. Okay, so we talked about implementation, set up a pipeline, compute these delayed rewards, add and try to model them in your ranking model, and train the weight for them in your value model. So now let's look at the math a little bit. So the value of a trajectory, as we saw here, the value of a trajectory is a sum of value at all points in the trajectory, right? But the math there was from the first point to the length of the trajectory. Here, note that I'm assuming you definitely get value from the first point. Why? Because in all of these examples, the first one is presented to you. The first one is presented to you. It is what you do. Like you could drop off immediately after that. So the minimum length of your trajectory is 1. So v tau being the trajectory, the value of the trajectory, is the value you got at the first position. And then from position I to infinity, a, like the value, you get a value from the ith position if and only if you have not exited before that. So 1 minus exit j, 0 to I minus 1. This just ensures that you have been not exiting till that time, and whatever value you get at that ith position. So once again, the value of the trajectory, the value of the first point, plus value of future points. To get a value of the ith point, you just need to not exit before that. Okay. Now, another way to look at this is the value of the trajectory starting the 0th position is the value of the first position plus that you didn't exit the 0th position, the value of starting at the second position, right? Second being 1, I've still done 0 and exit, but get the picture. Now, if you look back at our implementation, we were taking 0 position, computing the discount to reward, and attributing it to the first item. This is like, apart from the discounting, we also do discounting, which is not written here. Apart from discounting, essentially, this is the part that we are trying to attribute and predict from the first item. So we are saying the first item contributes to not just this, but this also. Okay. In one conjecture or one direction to look at is, if you believe my word that, hey, this retention modeling thing works, what I don't know is that is a large reason that it works because the first video affects this term, which is the probability of exiting at that position. What I'm trying to say is that suppose you have a baseline estimate of all the value the user will get starting at position 1. Okay. This baseline estimate, let's say for instance, is not even dependent on what you predicted. Maybe it's just purely dependent on the user. Power users will get a lot more value here in average and things like that. So could we have achieved the same excellent results of retention modeling? So instead of this entire term, could we have achieved the same effect by just trying to predict this well with the first item, and this part of the prediction could be done only with user features, which means that could be a function of purely the user state and not the item recommended. Because if this is the case, then I think it at least clearly explains the causality that, the first item has the reason it affects not just by this term, but also by this term, is because specifically the exit probability at the 0th position has a high impact due to the item you're recommending in the 0th position. So in other words, is a large part of the gain of predicting the full trajectory can be purely achieved by by modeling the probability of exiting at the zeroth position. Okay, so to recap, we talked about the core idea here is that we are not just modeling the immediate impact, but modeling the long-term impact. There are some papers by Google that have done that in the past and explained the problems of doing that. We focus on entry points only, which are either in the carousal entry point or tab entry point. Then we talk about the benefit of entry point recommendation. So, for instance, it can lead to a reduction in single item sessions, or otherwise longer sessions, increase in the number of times users open your app, the number of daily active users, etc. Then we sort of talked about the key insights and how that translated into implementation. And then we talked about some of the mathematical derivation and how the implementation below leads us to predict a discounted sum of the second term. Hope you enjoyed this, and this has been. Yeah, I'm personally a big believer in this approach. I've seen it work. I've seen it. Let's just say I've seen it work wonders. So, if you're in this if you feel like you are in this sort of a chained experience, an experience where there are a number of recommendations that one after the other, take my conviction for what it's worth. But I think it could help. Thanks.